What's going on? We're going back a few days to Philip Newman's Sudoku XL. We got normal Sudoku reply. We have diagonal and region sum lines. Let's see what we can do. Diagonals, excuse me. All right, so this is going to be, it's a length of 3, which is equal to this. So it has to be a 6, 7, 8, or 9. And it can't be a 7 and it can't be a 9. So this is a minimum. So that has to be a 6 or an 8. This can be 6, 7, 8, or 9. 1, 2, 3. This is a 7 or a 9. 1, 2, 3, 6, 7, 8, 9. This is going to be a 6, 8. This would be a 7, 9. Okay. Can I figure out any more? Yeah. 1, 2, 3. So this is 6, 7, 8, 9. 6, 7, 8, 9. Okay. Those are all marked. So then we need a 1 in this box. So it has to be on one of those two. 4 has to be down here. So if this is a 4, I think, can a 9 be with a 4? 2 and 4 would be 6, and we would need a 3. So because this is a 3, I think this has to be a 7. I think that's right. Right? Because it was a, let's see, so it was a 7 or a 9. And if it's a 9, that could be a 1, 2, maybe 3, 1, 2, 6. No, that could be a 9 still. It could be a 9 still. Yeah, 1, 2, 6 would count. Okay, yeah, let's leave that as it is. You can put 3s there. 2s here. 4s, 2s. Okay. I get it. 1, 2, 3, 4. Now a 7 has to have a 1 on it because the only option for 7 is a 1, 2, 4. So this has to be the 9. All right. And this cannot be a 9. All right, got one number. And then in this box, can't be here, can't be here. Cannot be in its own region sum. It's there or there. All right, and again, this can't be a 6 or, wait, this can't be a 6 or a 7. Because 6 and 7 both need a 1. So this is now an 8, 9. Can it be an 8? No, it can't. Because if it's an 8, then there would need to be... So it can't have a 1 or a 4. All right, sorry, can't have a 1 on it. So this would be a 7. Without a 1, this equals 7. And we know this 7 has to have a 1, 2, 4. So this is also a 9. So we can place the 9 there. So then this cannot be a 9. And we need a 9 in this box. So it can't be here, can't be here, and it can't be on a region sum. So this is the 9, which places this as a 3. All right, so then we know this. These cannot be 9s. This cannot be a 9 or this. So 9 is going to be here. Nothing. That's not enough right now. But in this box, can't be here, can't be here, cannot be on a region sum with multiple. Actually, yes, it can. It can be on a region sum, but it can't be if one of the regions is only a 1 digit. Because if this was 2, a distance of 2, then this could be a 9 and an 8. So it'd be a 17, right? So then this could be a 9 plus 4 and 5 and 3. Okay. Yeah. I think that makes sense. 9, 9. So then this is a 9. And then this can't be a 9 because the 9 is already on that diagonal. So we have a 9 here. So this cannot. So this is now a 7. And then this is also a 9. So we put a 9 down here. So we can move this 9, and then the 9s are done for the puzzle. Okay, so we know a 4 has to be on the region sum because the 7 factor is only 1, 2, and 4. So we can put 1, 2, 1, 2 there. All right. Okay, so where's the 6 in this box? 6 can't go in this column, and it can't be on this region sum because this is 6, 7, or 8. So if this was a 6, this would have to be a 1 and a 1, or a 1 and a 0, which is impossible. So we're going with the 6 there. Move that 6, which places 6 here. 6 is here. Okay, so this is all right, what else can we figure out? So 8 can go here or here. All right, so 2 on this row. All right, so it can't go here. It can't go here because we have a 1, 2 pair here. So this will be the 2. All right, and if it's a 8 minus 2, then we need a 5, 1, or 2, 4, which can't have. So it's going to be a 5, 1. All right, or no, not necessarily. Not going to be, well, what am I talking about? 1s are here, so this is also 1. That solves it anyway. So this is going to be either 4 or 5. So this is going to be a 4, 5 pair. And so that, if this, whatever this solves, this also solves. Okay. So then this is also a 7, 8. All right, and then we know 4 has to be up here. So if this is a 4, this would have to be an 8, and then that'd be a 1. So we know that the 1 is over here on the row. 1, 2, 3, 4, 5, 7, 5, 1, 5, 6, 7. Oh, gross, excuse me. All right, 7 in this box is limited to these two because it can't be on that region sum with a 9 equal to a 9 because it would have to be 7 plus 1 plus 1, which is impossible for multiple reasons. All right, so 1 can't be here, can't be here, can't be there, so it's here. So that can't be a 1, so it places the 1 there. And then this can't be a 1, so it places the 1 there. So this is a 1, 3, that equals 4, and it can't be a 2, so this can't be a 6. I could have figured that out ages ago, so that's a 4. So this is a 7, so that's also 4, that'd be the 5. 1, 2, 3, 4, so then we know is 8 gonna be up there, so this can't be an 8. Oh, this is now a 6, which puts that as a 5. This will be an 8, and then this is a 7. So this will also be a 7. 1, 2, 3, 4. Then we have 5, 6. All right, so this is a 6. Then we have a 1, 2, 3. 1, 2, 3. That can't be a 1. That can't be a 2. That can't be a 3. 2, 3, 4. And then this becomes a 5, 6, 8. So we have a 5 here and then 6, 8 pair, which puts, that's a 1, 2, 3, 4. So this becomes a 5. Something in my eye. All right, that's a 5. Then we have all right, what do we need? We need a 2, 2, 3, 6, 8. All right, so this is a 6. 8 cannot be on a region sum, so we put 8 here. And then we have a 2, 3. So this can no longer be a 3. So that's a 1, that's a 2, that's a 3. So that'd be a 1, 2. Wunderbar. Okay, all right, okay. All right, this can't be a 6. So we have 2's over here. 3. Where's the 3 in this box? 3 can't be here or here or here. So 3's go there. And this is the only spot it could be on the diagonal, and it has to be on a diagonal. So then this becomes a 5-6 pair. Okay. Okay, so this cannot be a 7 because it has a 2 in the box, and a 7 options can only be a 1, 2, 4. So this is an 8. And then this is a 5, 4, 3. So it has to be a 4, 3. So I'm going to put 4 here, 3 here. And then this will be the 4's. 1, 2, 3, 4, 5, 6, 7. So this will be the 7. 5, 6. And then this is a 3. 9. So I think it has to be a 3, 2, 4, right? I think so. So 7's are here and here. So this becomes a 4, 5, 6 triple. So I can place the 4 here. So 4 is there. This is a 4. So that's 7. So this is a 2. And then we can remove that 4. All right. So this is now a 3. That's a 2. 1, 2, 3. Then we need a 4 and 7. So 4 goes here. 7 is there. So that's not a 7. Then this becomes a 5, 6. Oh, and then we can place 5 and 6 there. So then this becomes a 5. That's a 6. 5, 6. So this is a 5. And that's a 2 to finish off. So we need a 6, 8. So this is an 8. That's a 6. That's an 8. 3, 4, 5. Then we need 6 and 7. So 6 will go here. That's a 7. So that's a 7. This will be a 3, so that's a 2. Then we need a 5 and an 8 to finish off. All right, nice work. Good stuff, Philip.